Find the largest number which divides 615 and 963. 615 and 963. Leaving remainder 6 in each case. So we have to find the largest number which divides these two numbers, leaving remainder 6. Right? So what is the largest number? Okay, when it divides these two numbers, it should leave remainder 6. So now if we remove 6 from both, this becomes 609 and this becomes 957. So the same number, if we divide it to these two, it will leave remainder 0. Which means we have to find HCF of these two numbers. And I'll use prime factorization method. I'll use fundamental theorem of arithmetic method, which means we have to do prime factorization. Now 9 plus 5, 14, 14 plus 7, 21, so divisible by 3. So 3 ones are and 9. 9, 10, 13, not divisible by 3. So not divisible by 5, so I'll check for 7, 48, 28 and 3 remainder, so not divisible by 7, which means next I have to check for 11, definitely divisible. So it is going to be divisible by 11. So 2s are 22. Remainder is 9, 99. So 9s are. And here the answer is, it's a prime number, so 29. Now here again divisible by 3. So 203. Now 203, is it divisible by 11? No. Which means I am pretty sure it is divisible by 29. So 29 and the answer has to end with 3, so I'll multiply by 7. 9 7s are 63, 7 2s are 14, 203. So divisible. We should have checked for 7 first. So what I'll do is I'll do a little scam and write 7 first. Always start from the lowest to biggest numbers, alright? But this was just to show you, since 29 was here and 11 we cannot divide, I was pretty sure that it was going to be divisible by 29. So 7 into 29 and 29 and 1. So one pair of 3s are common, one pair of 29. So HCF will be 3 into 29. So the number 3 9s are 27, 3 2s are 6 plus 2, 87. So the answer is 87. When you divide these two numbers by 87, it will leave remainder 6 in each case. Right? The length of 3 rods are 6 meter, 75 centimeter, 8 meter, 25 centimeter and 4 meter, 50 centimeter. Alright, they have given us 3 rods, each having these lengths. Now they have asked us, determine the length of the longest rod which can measure all 3 rods accurately. So you have, what is the longest rod which can measure all 3 accurately? If you are using one rod to measure all 3, it means that rod cannot be bigger than any of these 3. In fact, it cannot be bigger than the smallest rod as well. It can be equal to it, but it cannot be bigger, which means it is a HCF problem. So now I'll convert this to centimeters for easy calculations. 6 meter 75 centimeter is 675 centimeters. Okay, I'll just directly write here. This is 825 and this is 450 centimeters. To find HCF, I'll use prime factorization. So will it go by 3? 13 plus 5, 18. So it will go by 3. 2, 2, 5. Will it go by 3? Yes, it will go by 3. 7, 5. Again it will go by 3. So 3, 2, 5. Now by 5 and 5 and 1. Now will this go by 3? Yes, 15 is the total. So since 15 is divisible by 3, this is divisible by 3. 2s are then 22, 7s are 15, 5. Again this is divisible by 3. No, it is not divisible by 3. Because 2 plus 7, 9, 9 plus 5, 14. So I'll go for 5. So 5 5s are 25, 25, 5. So 5s are 11, 11s are 1. Now this divisible by 3. So 1, 5, 0, 3, 5, 0, 5. We should have started with 2 people. Okay, but no problem. I'm not doing what I have told you to do. Okay, So we'll see what is common. One trio of 3s, one trio of 5s, and is there anything else common? Yes, there is one more pair of 5s common. So HCF is 3 into 5 into 5 equal to, so 3 5s are 15, 15 5s are 75. So the answer is 75 centimeters. The longest rod that you can use to measure all three accurately is 75 centimeters. In a seminar, the number of participants in maths, physics and bio were 336 in maths, lot of people for maths. Physics was 240 and bio was just 96. So in a seminar, these many people are attending for maths, bio, physics and bio. Find minimum number of rooms needed. So we have to find the minimum number of rooms needed if in each room same number of participants should be there and are of the same subject as well. So now, okay, the way I explained word problems in the previous module, the number of rooms cannot be more than the number of people. So you already know that it is a HCF problem. So first we'll find the HCF of all three. So we have to prime factorize all three. Okay, 336, 240 and 96. Alright, now 2 1s are 6s are 8s are 2 84s are 2 42s are 2 21s are 3 7s are 7 1s are 2 120s are 2 60 2 30 2 15 3 5 5 1. Then again 2 4s are 8 1 6, that is 8 2 24 2 12 2 6 2 3 3 1. We have to find HCF. One trio of 2s are common, another trio of 2s are common, another trio of 2s are common, one more trio is common and one trio of 3s. There is nothing else common. So HCF is 2 into 2 into 2 into 2, 2 into 2 into 2 into 2 into 3. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 into 3, that is 48. Now this is the HCF. But what is this 48? When we take HCF of these three people, we are getting that the ideal, if we want to divide them equally into groups, there will be 48 people in each group. But the question is not how many people in each group, how many rooms are needed. So we need, in each room we can put 48 people. So how many rooms are needed? We have to divide each by 48, right? So for 336 people, if we divide them into 48 people, how many rooms will be needed? 24s are 168, 24 12, 84, 12 6, 42, 6 1s are 7s are. So for the first group, 7 rooms will be needed. Now for the second group again, 120, 24, 60, 12, 12 1s are 5s are. So for the second group, we'll need 5 rooms. And for the third group, 1s are 2s are. So 2 rooms. So total number of rooms, 7 plus 5 plus 2, 7 plus 5, 12, 12 plus 2, 14. So the answer is 14. Now the fourth question in this test. 3 lights blink after every 40, 42 and 45 seconds. So 40, 42 and 45 seconds. So after 3 lights blink in this much time. If they start together, after how much time will they blink together again? Obvious, the answer has to be more than this, which means it's a LCM problem. So 40, 42, 45. Because each light is blinking after different amount of time. If they're starting again, the first light will blink after 40 seconds, next light after 42, third light after 45. The second time this blinks is after 80 seconds, this will be 84 seconds, this will be 90 seconds. So they are still not blinking together. So after how much time? If we take the LCM, we'll find the answer. So again, using fundamental theorem of arithmetic, 20, 10, 5, 1. This 2, 21, 3, 7, 7, 1. And this 3, 15, 3, 5, 5, 1. So how do we find LCM? First one trio of, nothing, no, 2's are not common. Which means, is there anything common in all 3? There is nothing common in all 3. Which means, to find, okay, now, remember people, since there are 3 numbers, we have to take common in each of the 2 pairs. So there is 1, 2 and 1, 2 common here. That's it. 1, 3 and 1, 3 common in these 2. That's it. Now in these 2, 1, 5 and 1, 5. I have marked all 3 differently. So these 2 2's will take only ones. These 2 3's will take only ones. And these 2 5's will take only ones. And then multiply with whatever is remaining. 2 into 2 into 7 into 3. So what do we get? 2 3's are 6, 6 5's are 30 into 2 2's are 4, 4 7's are 28 into 3. 30 into 3, 90 into 28. So I do 90 into 28. 8 zeros are 0, 8 9's are 72. 2 zeros are 0, 2 9's are 18. So 20, 5 1 2. So answer is 2 5 2 0. So after how long will all 3 lights blink together again? After 2520 seconds. Which number, when increased by 7, will divide 204 and 336 exactly? Right? Now, which number when increased by 7 will divide these 2 exactly? It has to divide these 2 means the number is smaller, which means HCF problem. So now we have to find HCF of these 2. So 336 and 204. Again using fundamental theorem of arithmetic. I like this method, it's very nice. That's why I use it a lot, but you can also use Euclid's division lemma. So 2 1's are 1 remaining, so 6 are 8, 2 84, 2 42, 2 21, 3 7 7 1. Here 2 1 0 2 2 51, 3 1 17 17 1. So one pair of 2 is common, another pair of 2 is common, one pair of 3 is common, right? So what is the HCF? 2 into 2 into 3. So 2 into 2 into 3. 2 2's are 4, 4 3's are 12. So 12 will exactly divide these 2. But what was the question? X, which number when increased by 7? Which means when you increase the number by 7, you should get 12. Which means what is the answer? X is equal to 12 minus 7. So the answer is 5. When 5 is increased by 7, it will exactly divide these 2 numbers.